Video meet ಮಾಡಲಿ. Hello, good morning. Hello. Hello, good morning.
Sir, good morning, sir.
Good morning, sir. ಇದೆಯಲ್ಲ? Clarity ಇದೆಯಾ?
ಇದೆ sir, clarity.
Voice clarity ಇದೆಯಾ?
Yes, sir. Yes, sir.
Okay, sir.
It is audible.
Start ಮಾಡಲಿ?
Sir, 10, exactly 10.
Exactly 10. Okay, sir.
Okay.
ಕೊಡೋದು ಟ್ರೈ ಮಾಡ್ತೀನಿ ತಂದಿಯಾ ಸರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಓಕೆ, ನಾನು ಇವತ್ತು ಕೇಳಿದ್ರಲ್ಲ, ಅದಕ್ಕೆ ನಾನು ನಿಮಿಷ ತನಕ ವೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೆ ನಾನು. ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ. ನೀವು ವೇಟ್ ಮಾಡ್ತೀರಿ ಏನಾರ? ಓಕೆ ಸರ್, ಮಾಡಿ.
Good morning, everyone. Good morning to dear participants and resource persons. So, 5 days national level workshop, day 2, session 1. Today's session 1, our resource person is Dr. Maheswarappa B. It's our pleasure to welcome Dr. Maheswarappa B, Professor and Head of the Department of Electronics and Communication at STJIT, Ranebennur. Dr. Maheswarappa holds a PhD from VDU, Belagavi, and has an impressive academic background with 26 years of teaching experience. And he is an exceptional educator and mentor. His professional contributions are noteworthy, having conducted an Atal FDP in 2023, organized an international conference in 2016, and published numerous papers in national and international journals. We have honored to have Dr. Maheswarappa with us today and look forward to his valuable insights and contributions. Please join in the existing a warm welcome to him and thank you, sir. The session is over to Maheswarappa, sir. Sir, you can continue the session, sir.
Okay. Good morning, one and all. I am Dr. Maheswarappa B, Professor and HOD, Department of PNC, STJIT, Ranebennur. Today I want to talk AI image processing. First, we want to see what is AI and what is an image, what we do in the image processing. See, first we see some images. In these images, if the human beings definitely identify that person who are in the, or what are the object present in the images. Like this. See, what are the animals? We want to identify which kind of the animals. And in order to do these, some process we want to do. Now our aim is what human beings is doing, our system should do. That means our computer should do. So that AI artificial intelligence AI is a branch of computer science that aims to create the machines that can learn, solve the problem, and create like a human. Some basic concept of AI includes. Our basic aim of this AI is our machine should do as human beings. For example, if we see anything, he is able to identify which object is there, which animal is there, and what are the things are there. Like that, our computer should do. That one we call it as an artificial intelligence. That because he is created by the human beings. For this, there's some basic concepts are required. The basic concept of AI includes machine learning, a method of teaching computers to learn from the data to improve their performance. That means, as a human beings learning some concept, our machine should learn. For example, we already know that if you have your mobile, your friendly fingerprints, in order to get the security from your fingerprints, first you should teach our fingerprints patterns to our machines. That means so many images, scan images we store. After that, if you put the fingerprints, that will match with the old saving images. If it is authenticated person, at that condition, your mobile is open. And so many formats are there in order to teach the machine. From that, machine will learn. First basic concept is our machine learning. After that, deep learning, a method of using neural network to process the complex data and improve accuracy. That means our neural system, how act like that, we're going to design the neural network that will sense the input and give the response as an output. In the last session, we already know that basic. That's a Chetan Kumar sir. Chetan sir explained very beautiful that neural network design as an input layer, hidden layer, and output layer. Like that input, which organ is sensing that parameters, that one we call it as a input nodes, and output nodes that giving the responses. This inner thing is so many things is happening that is not appear to us. That layer we call it as a hidden layer. For example, if I touch any art material, at that condition, our skin is sense that art body, and that signal is goes to our brain. That will give the stimulus for the output. Output means we taken back our hand from that art material. But inside, so many things is going on. Like that, our machine should learn. That kind of learning, we call it as a deep learning. Another kind of concept is natural language processing, NLP. A method of enabling the computers to understand and interpret and generate the human language. For example, natural language, but basically computers understanding only machine language. Every digital system is understanding only 0-1 forms. That's a switching on and off that much only. But nowadays we are giving typing some commands that is understood by our computer. Nowadays, if you speak, that are so understood by the computer. That's a higher level language or natural level language our computer should understand. After that should interpret and generate some response as a human being. That we call it as a higher level language. See here, these are some AI. First one is generative AI. A method of using the neural networks to create the responses based on the patterns learned from the data. For example, so many animals are there. In that one, we are going to identify which animal First, we should teach what are the patterns of that animal to the computers. From so many data, we're going to teach from that our computer generate the response that based on the patterns learned from those data. Next one is neural network. Neural network is a model of AI that uses the layer of interconnected nodes to process the data and produce the output. I already told in the neural network 3 layers. One is input layer, next last one is output layer, next in between there's a hidden layers. That nodes are interconnected. That model, what purpose we designed that model, that desired work that should do. Take the response from the input nodes or input layer and produces the response in the output layer. But in the hidden layer, so many processing is going on. That's similar to that of your brain. First, if you see anything that our eyes is catching that one, or our skin is catching that one, that as an input. After that, for that excitation or for that input, our brain produces the output. The so many things are going on inside the brain. Our computer should functioning like that, our brain, that taken care by this neural network model. That model acts as a similar kind of work as doing by the human brain. Next, computer vision. A method of enabling the computers to extract the information from the images. Say images are there. From that one, we want to classify that images, or we're going to target or identify any object which one we need. For that, first we're going to extract what is the information is there from that images. For example, similar to that of your fingerprints. The fingerprints having there's a rods, hole, different formats like that. First, that information we going to extract and train that our system. After that, we're going to test it, putting in our fingerprints that either that showing the authenticated or not. Afterwards, there's a large language models, a type of generative AI that focus on the understanding human language. Nowadays, we are already familiar with that one. Our AI is generating some images by understanding the human language. For example, your mobile is also, if you speak something, if you want to open anything, you want to use your language that will understand it. According to that command or your thoughts, that will give you a response. That one we call it as a large language model. It understanding the higher level languages, after that converting to the machine level language, that machine will understanding that and machine will give the response for that language. Next, narrow AI, a type of AI designed to perform the specific task such as facial recognition or something. For particular only one task, we designed that AI at that condition, there's a fast response that we need. Where we need the fast response. At that condition, you go for the narrow AI rather than large language models. Thus, a prompt engineering, a method of guiding the generative AI model to produce the desired result. If the target, what purpose we design that AI, that desired target we need at that condition, that our prompt engineering is guiding us generating AI. AI is used to automate tasks and improve the decision making in many industries. For example, nowadays, the packing of the vegetable oils or filling the anything, we already settled with that AI. AI models are taking responsibility to make the decision and also quality checking. All those things is done by the AI in many industries. Now we're going to classify that primary AI. There are 4 primary AI types. According to the current system of classification, there are 4 primary AI types as follows. First one is reactive. Second one, limited memory. Next one is theory of mind and self-aware. Let me explain one by one. What is reactive AI? The most basic type of the artificial intelligence is reactive AI, which is programmed to provide a predictable output based on the input. It receives reactive machines always respond to identical situation in the exact same way every time, and they are not able to learn actions or consume of past or future. That's what kind of input we are giving, that our model is understanding and give the reaction for the particular. That reactive machines always respond to the identical situation for what purpose we design. Okay, for that only, that way. For example, the chess playing. For example, opponent to 2 persons are playing the chess. That some rules and regulations already feed to our system. That system is playing one side, that's a manually another side. If I move any coin, that should take the input, that one. For that, what is the optimal solution? Which coin going to move? Like that, our system is playing the chess. Okay, that means there's an opponent which coin is moving. For that taken as a problem, that will calculate. So many solutions, so many movements are possible in that one. But which one is the optimal solution? Which movement is giving the optimal solution? That coin movement is taken by that system. And next one is however, see here, next one is limited memory AI. Limited memory AI learns from the past and builds experimental knowledge by observing the actions or data. Thus, a limited memory AI is taking the excitation or actions as similar to that of actions or that learn from the data or getting the knowledge from observing the action. For example, I want to simulate the Shah Rukh Khan actions or Punit Rajkumar actions. First, we are going to teach the and different actions format of these stars. Our AI is learn and reproduce. At that condition, one action to the another action. That means one frame to the another frame. That's a difference. That difference we want to find out and predict to next. Like that, our AI is using a response. That means limited memory AI is giving the response by the past observations or historical observation or combination of pre-programmed information to make the predictions and perform the complex classification tasks. It is the most widely used kind of AI today. Nowadays, some researchers are trying to use the solution or animate the actions of so many other heroes, their pattern, their styles, all those things. Here also we are going to observe some, for example, autonomous vehicles uses limited memory AI to observe other cars and the speed in which direction, helping them read the road. First, we want to read the road situation. After that, adjust the speed and direction of the cars and adjust as immediately it is needed. That one is adjusted as per the reading of that road. This process for understanding and interpreting incoming data makes them safer on the roads. However, limited memory AI, as its name suggests, memory is limited. The information that autonomous vehicles work with repeating and it is not saved in the car's long-term memory. Thus, what the situation comes, for that situation only it will take and store that one. After that, after some time, 5 minutes or 10 minutes, its memory will lose. So that this one we call it as limited memory AI. Next one is area of mind AI. This is a meaningful observation into the emotionally intelligent robot that looks and sounds like a real human being. Now it is actually a real challenge for modeling or designing the model for the AI. The same theory of mind means till now only there's a classification, there's a identification, recognition, this much we are doing it. But our system is understanding the emotions of the humans. There's a feelings like that. Okay, that is very challenges. Still research is going on the theory of mind. Theory of mind means how we are thinking. Like that, like that our system should be think. For example, in the 1996, one of the scientists is introduced the IC in the human body. That will capture and give the status of the what kind of thinking he is thinking. But Supreme Court is banning that research work because that is very much dangerous development to the human beings. For example, ನಾವು ಹೇಳಕ್ಕಾದ್ರೆ ನಮ್ಮ ಮೈಂಡಲ್ಲಿ ಏನು ಇದೆಯೋ ಅದನ್ನ ಏನಾದರೂ ಕ್ಯಾಪ್ಚರ್ ಮಾಡಿದ್ರೆ ಸೇಮ್ ಇನ್ಫಾರ್ಮೇಶನ್ ತಗೊಂಡ್ರೆ ಸೊಸೈಟಿಯಲ್ಲಿ ಸಂಬಂಧಗಳು ಬಹಳ ಹಾಳಾಗ್ತವೆ. ಅದೇ ಪರ್ಪಸ್ಗೆ ಆ ರಿಸರ್ಚ್ ಅನ್ನ ಬ್ಯಾನ್ ಮಾಡಿ. With this type of AI, machine will acquire the true decision making capabilities that are similar to human, but not 100%. Still today, we are not getting the 100%. Machines with area of mind, AI will be able to understand the remember emotions, then adjust behavior based on those emotions as they interact with the people. See, some of the films already released, robots. They are designed the robots in such a way that robots are understanding the emotions of the human beings. Laughing, that's a short, caring, all those things. That's how the human feelings are. Our emotions are changes that understand by our models that will give the reaction perfect. That means that robots also understanding the emotions as they interact with the people. ನಾವು ಮನುಷ್ಯರು ಯಾರು ಮಾತಾಡ್ತೀವೋ ಅದೇ ರೀತಿ ನಮ್ಮ ರೋಬೋಟ್ಸ್ ನಮ್ಮ ಫೀಲಿಂಗ್ ಅನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಕೆಲಸ ಮಾಡಕ್ಕೆ ಆಗ್ತೀವಿ. See, this training of those data is very difficult. We achieve so much, but unable to 100% emotions is not yet solved. There's still a number of hurdles to achieve theory of mind AI because the process of shifting behavior based on rapidly shifting emotions is so in human communication. For example, ನೋಡ್ರಿ ನಾವು ನಗ್ತಾ ಇರ್ತೀವಿ, ಹಂಗೆ ಒಂದೇ ಕ್ಷಣಕ್ಕೆ ಬೇರೆ ಎಮೋಷನ್ ಅಳ್ತೀವಿ. ಆ ಎಮೋಷನ್ ಶಿಫ್ಟಿಂಗ್ today is not possible from our AI. This random or rapidly shifting emotions are changing these emotions are very difficult to teach in our models. And it is difficult to mimic as we try to create more and more emotional intelligent machines. Nowadays, research are going on to train up or create such emotionally intelligent machines. That we are making process with this robot yet developed by the Professor India could recognize the emotional signal on human faces and replicate those emotions on its own face. Humanoid robot Sophia, developed by the and some robotics in Hong Kong can recognize the faces and respond to interactions with our own facial expressions. That means that scientists developed that robots interaction with our own facial expression. How expression changes by us. For that robot is giving the expressions. In that robot too, I think in that movie they are shown that understanding the emotion or feelings of the human beings. Next, self-aware AI. This one is the most advanced type of the artificial intelligence in self-aware AI. When machines can aware of their own emotions as well as the emotions of the others around them, they will have a level of consciousness and intelligence similar to human beings. This type of AI have desires, needs, and emotions as well. This is self-aware AI is the most advanced model that will understanding the emotions of the others who are around them. That level of understanding and he is giving the response like as a human being. So that this is designed for that like that of human beings. Machines with this type of AI will be self-aware of their internal emotions and mental status. See, if the person is ready to respond internal emotions and the mental status, if the machine is able to give the response or understanding the internal emotions and mental status, at that condition our machines act like a human beings. They will be able to make inference such as I am feeling angry because someone cut me off in the throat. But like that giving the or inference or giving response through the or presenting feeling of anger or happiness, all those things that are not possible with other type of the AI. With AI is self-awareness, this one is the advanced, this one only today understanding the feelings of the human beings and giving the response like the human beings. We have not developed this type of sophisticated AI yet and did not have the hardware or algorithm to support it. Like that feeling, for example, any hardware or sensor are required to take the response, and that hardware should react. So that such a hardware not yet be available, but algorithm, that's our program, is not yet support to the run the or reacting that hardware in self-aware AI. Now, image processing. Now, pass on to the image processing. Thus, we discussed only artificial intelligence. Now, we want to use this artificial intelligence to the image processing. First, let me explain what is image. We have captured that images from the camera. That image for our machines that in the form of pixels only. We already know that pixels or pels are the building blocks of images. Again, those pixels, how many pixels we taken from the unit area? For example, 1 centimeter by 1 centimeter or 1 millimeter by 1 millimeter. This becomes the resolution of the camera. Number of pixels increases per unit area. The resolution of the images is increases. The quality of the image is depending upon the resolution. But at the same time, data will be moved. This similar kind of the one, we are already familiar with the Rangoli. Now Rangoli activala mane munde adi reeti. Ononde chukke itre aa chukke assume that's a pixel. Allond pixel itre that image blur kaanatte, continuous kaanalla. Ade ಜಾಸ್ತಿ pixel itre image clarity ಚೆನ್ನಾಗಿರುತ್ತೆ, ಚೆನ್ನಾಗಿ ಕಾಣುತ್ತೆ. But number of pixels are more. Number of pixels per unit area is nothing but the resolution of the camera. That if the resolution of the camera is increases, the quality of the images taken by that camera is increases. But here we are familiar with those pixels. We are playing with the image in the image processing. We are playing with that one only. We are going to manipulate those pixels. Again, those pixel value we going to changes depending upon the intensity or luminous intensity of the pixels. That's 256 levels we are making, 0 to 255 levels. That scale we call it as a grayscale. Grayscale is very, very important for the any kind of image processing. In the image processing, what we are doing and how we are artificial intelligence technique that uses. First one is to analyze that images. Next, manipulate and extract the information from the images. AI image processing can be used for variety of the tasks, including enhancing the image quality, recognizing objects, and predicting outcomes. See, in the images I told that's a grayscale important. That's a 0, for example, 0 intensity that seems to be black. That's the intensity is highest, that's a 1. It seems to be white. That's a monochrome black and white images. Another images is that's a color images. As we know that 7 basic colors are there that we call it as a width depending upon the wavelength, that color changes as we know. But for creating images, we are only using 3 colors: RGB, red, green, blue only. This is sudden question arises. Why not the other four? Because every images seems depending upon the usual perception of our eye. This is usual for three colors, RGB colors. Take the more important than the other colors. By using these three colors, can be able to produce the more than 64,000 different colors. For that, again these three colors converted into grayscale. There's a 0 to 256 level, 255. Total level is 256. That one grayscale. Here, enhancing the image quality means if any noise is there, we're going to eliminate and deterioration taken place. We're going to again restore that which part of the image is deteriorated in such a way that we're going to enhance the image quality. Next, we're going to recognize objects. In the images, what kind of the objects are different kind of the object. For example, nowadays, in every toll highway, that will read the nameplate of the cars or any vehicles. In that one, there's a number and the alphabets. There's a text in that one that should recognize. Like that. And other objectives. For example, we're going to separate some fruits, different size. Mangoes, different size. So that first we're going to recognize size of that objects and classify depending upon the size, colors, different fruits like that. So that recognizing objects also one of the application of our image processing. Now we're going to image processing with the AI applications. I already told that image quality enhancement. What are the features in that image enhancement? Highlighting the features in an image by changing its brightness or contrast. There's a brightness in the grayscale 0 to 255. That means 256 level. Increase that brightness or contrast. By that, we want to enhance the image. Next, image recognition. Identifying the object in an image and determining what category it belongs to. For the classification of the images, recognize is very important. First, we are going to identify the objects in the images and how many different categories of the objects are there. Depending upon that patterns, we are going to classify. With, for example, if some triangles, some balls, some other objects are there in one bucket. If you take that images of that bucket and separate those objects as a category, as balls, triangles, like that. First, we going to identify which kind of the object. So that first extract the features, that means the patterns of that one. Using that, we're going to classify those objects. That what category, whether it is a ball, whether it's a triangle, or whether it's a animal. Okay, so many different choices. Next one, image restoration. Improving the look of an image using the mathematical or probabilistic models. There's a mathematical model, nothing but set of equations. Which part of the image or the blur image or destroyed image, we want to restore it. ಎಷ್ಟೋ ಸರಿ ನಾವು ಹಳೆಯ ಡಾಕ್ಯುಮೆಂಟ್ ಅನ್ನ ರೀಡ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಇಮೇಜ್ ರಿಸ್ಟೋರೇಜ್ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ದಟ್ ಮಾಡೆಲ್ probability are used. Next, face swapping. This technique is replacing the one person's face in an image or video with the another person's face. See, so many things we are seeing that one. The Amitabh Bachchan face, yaro film star face, yaro ಬಾಡಿಗೆ ಹಾಕಿ simulate ಮಾಡಿ ತೋರಿಸ್ತೀವಿ. That is one of the applications of this AI. ಇನ್ನು ಮುಂದೆ ಬಹಳ ಟ್ರೈ ಮಾಡ್ತಾರೆ. ನೆಕ್ಸ್ಟ್ ಫಿಲಮ್ಸ್ ಅವೆಲ್ಲ ಅಲ್ಲಿ ಮಾಡಬೇಕಾದ್ರೆ ನೆಕ್ಸ್ಟ್ ಪುನೀತ್ ರಾಜ್ಕುಮಾರ್ ಫಿಲಮ್ ಅನ್ನ ಮತ್ತೆ ಮಾಡಬಹುದು ಬೈ ಯೂಸಿಂಗ್ ದಿಸ್ ಟೆಕ್ನಿಕ್. ನೆಕ್ಸ್ಟ್, image generations. Creating a new realistic image using generative adverse networks, that GANs. In the last class, Chetan KR explained beautifully this adverse network, that's a GAN network, for generating or creating the new images. That means so many iterations method are there for that network. First, we want to put the one target of that image. First, create the one image, checking with that one, and that will do the response or how much difference is there for the target image and the created image. Again, next iteration that will change the sum rate. Again, produces until that generating the image up to 0 error or 0 difference comes. Next, anomaly detection, identifying the images that are abnormal or different from the normal classes. This kind of image processing and these applications we are using in the medical field, healthcare. So many diseases, that's a scanning taken place. In that scanning images, we're going to identify which kind of the disease by using some patterns or features of that images. First, we're going to extract that features and What kind of the features are responsible for this disease, either cancer or brain tumor? Different kind of the diseases, for that different features are obtained by seeing that features, that we want to classify whether there's a abnormal or normal image, or we want which virus or which disease is attacked in that. Next, so many tools for image processing with the AI. Nowadays, AI models, free models, or open source are available. One of them is OpenCV. An open source computer vision library with the algorithm for machine learning and computer vision. This is an open source available in net. Next, TensorFlow. An open source machine learning framework for the image processing. Next one is Google Cloud Vision AI, a cloud-based service that uses AI to analyze and process the images. Nowadays, see, so many that images are available in the free source. If you type any person's name or particular location, our generator will generating that person's image at the particular location. For example, Shubman Gill in the Prayagraj. If you type it in that machine, definitely that will give the Shubman Gill image in the Prayagraj location. That is generated by our AI generated or created. Now, see what are the fundamentals of AI in the image process. We now discuss with the AI separately, images and image creators or generators. Now we want to see what are the fundamentals of AI in image processing. AI image processing uses artificial intelligence to analyze and enhance the images. First, analyze that image. After that, enhance. Enhance means we want to increase the brightness or contrast, improve the quality of the images. It involves tasks like pattern recognition, object detection, and image classifications. Core technologies include deep learning, neural networks, and machine learning algorithm. But after this AI comes revolutionize healthcare, security, and entertainment, commit complex tasks and improving the accuracy. See some image pre-processing See these icons giving the some image processing steps. In order to do the image processing, some basic steps, pre-processing. Why pre-processings are required? Pre-processing means we're going to make our image ready to give as an input. Before that one, that image as a raw image only. It required image resizing, normalization, or removal of the noise. Okay. These things are clearly explained in the last session by the Chetan sir. So that I pass to that one. Important of pre-processing in here. Now, some common pre-processing techniques: normalization, data augmentation, resizing. These things are explained in the last sessions. The noising, removal of the noises present in that ROM. Now we are going to discuss impact of pre-processing on AI model performance. Here, improved convergence. What is convergence? If you do any processing at that condition, the proper pre-processing ensure that the input data is in optimal form, which helps AI model convergence faster and more stable during the training. If data is pre-processed data at that condition, our model is converged faster. Next, enhanced accuracy. Techniques like normalization and data augmentation ensure that the model learns effectively from the data, leading to higher accuracy and better generalization to the new breed. Next point one, reduced overfitting. Data augmentation increases the diversity of the training data set, helping to prevent the overfitting and improving the model's ability to generalize to the unseen data. Next, fourth one is computational efficiency. Resizing and normalization reduces the complexity and variability of the input data, leading to more efficient computations and faster training time. Now, some of the popular AI image generators nowadays is available. First one is Midjourney, known for producing high quality images that are often photorealistic. Next one, Stable Diffusion, Rian, Jasper Art, Umbo Dream, Canva, Leonardo AI. These are the some popular AI image generator available. This table gives the some comparison of the generators. Any queries?
Dear participants, you can
Hello.
ask any queries for the resource person? Any queries? Thank you, sir. Thank you for your insightful and wonderful session. Maheswarappa, sir. Thank you, sir.
Thank you, sir.
Dear participants, the feedback link will be shared in the Zoom chat box. The 15 minutes, fill the feedback and send.
ಮುಗೀತು, ಈಗ ಕಳಿಸ್ತಾರೆ ಅನ್ಸುತ್ತೆ.